All right. So what we're going to do is we're going to plot the motion here of a dropped ball. And it says we're going to use a scale of 1 centimeter equals 5 meters and draw the positions of the drop ball at 1 second intervals. Neglect air drag and assume that gravity is 10 meters per second squared. So to do this, we're going to use our distance formula. Distance equals VI times time plus 1/2 AT squared. It's up here on the board as well. And to be honest, we've been doing this one for 3 or 4 weeks now, so you should be at least somewhat familiar with it. So I'm going to go ahead and zoom in. All right, so at 1 second, the ball is fallen a distance. So what is the initial velocity of anything before you drop it? 0. So we have 0 times time plus, not supposed to be a plus, 1/2 times 10 times time squared, and at 1 second, time is 1. So to clear this up a little bit, we have D, 0 times time is 0. 1/2 times 10 is 5 times 1 squared. So my distance is going to be 5 meters because 1 squared is 1. 1 times 5 is 5. So my scale is 1 centimeter equals 5 meters. So at 1 second, my ball's right there. Hmm? 5 times 1 squared. All right, at 2 seconds. So same formula. This time I'm plugging everything in. I have 0 times time, which I know is 0. Doesn't matter if time is 2 or 87. 0 times any number is 0. Plus 10, 1/2 of 10 times 2 squared. So my distance is going to be 1/2 of 10 is 5. 2 squared is 4. So it'd be 5 times 4. So my distance is 20 meters, which on my scale, because 5 meters is 1 centimeter, it's going to end up at the 4 centimeter mark. So at 2 seconds, it's fallen this far. At 3 seconds. Oh, I'm using the scale that it talks about down here. It says 1 centimeter is equal to 5 meters. So at 3 seconds, distance is equal to 0 times time, which is 3, plus 1/2, 10, 3 squared. 0 times 3 is 0. Distance is equal to 5. 3 squared is 9, so it would be 5 times 9. Which would be 45 meters. So using that scale, my ball would be right here at 9 centimeters. So we're going to do the same thing for 4 seconds. Distance equals 0 times 4, 1/2 10 t squared, which, is 4 squared. Distance is equal to 5 times 4 squared is 16. $80 meters, which on my scale would be right there. Zoom out. One seconds, 2 seconds, 3 seconds, 4 seconds. What is acting on that ball to make it fall? Gravity. And we know that gravity on the identical objects is identical, does not change. So the only thing acting on this dropped ball in the y direction is gravity. The only thing acting on this ball when it's thrown in the y direction, so up and down, the only force, the only thing acting on it is gravity. Which means that it's going to fall at the same distance at the same time in the y direction, in the up down. It's not going to fall straight down like it did here in the x direction, sideways, but in the up down it's going to be. So I'm using a ruler. I cannot draw a straight line. To be honest, my straight lines, even with rulers, are kind of eh. So we're going to start there. 1 second. 2 seconds. 3 seconds. 4 seconds. What you should see, so I'm going to move that one over there a little bit, is that you have a nice curve fall. Not the best curve. You're just going to have to take it from me. This path that the ball travels, it's called its trajectory, which just means its path. And in this case, you've seen this shape in math class. If these are your 4 quadrants, you did either the upside down or the right side up umbrellas. That's your parabola. This is 1/2 of that parabola. So we call that shape a parabola. Okay, down here it says a lot of stuff that we've just covered. Then it says, how is the motion in the vertical direction affected by the motion in the horizontal direction? It is not. Huh? Because you can separate out the motions. So the only thing acting in the up and down direction is gravity, the same as it is for this one. So since they're at the same height, they have the same mass, they're both on Earth, they're going to be the same. Now notice the ball didn't fall straight down like it did when it was dropped. So there is some horizontal action going on, but as far as up down, it's just gravity. All right, I'm going to write my notes in the back of this and then glue a strip of glue up here and fold it in half, put it in my notebook. If you'd rather take your notes on line paper, that's what your notebook's for as well. I just like to conserve paper. Today. You should have some time after quiz. All right, so steps to solve horizontal projectiles. We're going to break these down in steps so that you know exactly what to do. First step. We're going to split the motion into x and y components. I'm going to zoom in a little bit there. As a reminder, x is side to side or horizontal. Y is vertical or up and down. Then you just sketch your motion. It will not take long, just so that you can kind of look at everything you know. It helps to sketch it. In physics, it's part of the problem-solving process. And number 3, fill in what you know. We've been doing acceleration now for a couple weeks, so there are some things that you know, even though you don't think you know. For instance, what is the acceleration of any object on Earth in the up and down direction, in the y direction? 10, right? 10 for easy math. It's really 9.8. We're doing easy math, so 10. And we call this gravity, and we know it. So, in the y direction, it's being acted on by gravity. In the x, there's no forces in the x direction acting on it. There's no pressures or anything. Once it has left the hand of whoever's throwing it, or the muzzle of the cannon that's firing it, or however it got in the air, once it's left that object, there is nothing else acting on it in the x direction. So it maintains a constant velocity. When something has a constant velocity, its acceleration is what? 0. So a of y is 10, a of x is 0. My initial velocity of something before I drop it is what? 0. Before I drop my pen, it's not going anywhere. My initial velocity in my x direction is going to be whatever the speed it's thrown at or launched. So maybe it's launched out of that cannon at 140 meters per second, or it's thrown at 2 meters per second. Whatever it is, that's part of the problem. That's part of whatever it's going to be given to you usually, or you can solve for it. Now we're going to draw and fill in a chart. Where? Sorry. Simple math skills, man. They get me every time. 4. Draw and fill in a chart. My X, my Y, and I'm going to put a column between them. Make my freaking lines even. All right, we have acceleration, distance, initial velocity, and time. Those are going to be the main things that you're solving for. You could solve for final velocity as well, but these are going to be the main things you solve for. All right, some things to keep in mind with this. It's going to have the same time if it's dropped or if it's thrown. The video we just watched proved that. So time will be the same for both of them. The faster an object is launched, the farther it will go. If you throw something at 2 meters per second off a cliff versus 4, it's going to go twice as far in the X direction if it was going 4 than if it was going 2. It's still going to take the same amount of time to get to the ground, but it's going to have traveled further distance. Okay, so we're going to fill in this T-chart. Acceleration, see that? Acceleration in the X direction, 0. And the Y, 10 for easy math. Initial velocity in the Y direction, 0. I know this. This is what I'm expecting you to know on the test, is how to get this far. Everything else can be filled in from the problem. Go ahead and write this example problem for me. If a boy throws a ball at 5 meters per second off a 10-meter cliff, how long before it reaches the ground? question mark, not a statement. So we got to think about this in the x, it's in side-to-side motion and up and down motion. So here's my cliff. It's 10 meters. Launches. It's launched at 5 meters per second. And the only thing making it fall down in the up and down direction is going to be gravity. That's a sketch. Maybe instead of putting gravity, I'd put 10 meters per second squared. That's a sketch. It's not that difficult. We're going to make our t-shirt. All right, we know in the y direction, acceleration due to gravity at 10 meters per second squared. In the x, acceleration is 0 because there's nothing forcing it after it leaves that, in this case it's a hand, after it leaves the boy's hand. Guys, this is on your test. I need you to put your phones up, please. I don't want to hear you whining later. I don't know what's going on. You've been playing on your phone. Stop watching TikToks, class. It says if a boy throws a ball at 5 meters per second, so that is my VI. He's throwing it horizontally, so that's my VI in the x direction. In the y direction, it's 0 because the initial velocity of anything that you drop, before you drop it, it's going 0. And it says a 10-meter cliff, so that's a distance. If it's 10 meters high, is that in my x direction or my y? Y. Let's go ahead and put my units. That's all I know from the problem. To solve this, you want to use the side that you know the most of. Write that down, then we'll discuss it. Use the side you know the most of. So in this case, I have less blanks on my y side. So I'm going to use my y side. Which means right now, I am not worried about my x. I'm never really worried about my x's, but in this case, I'm not worried about what's going on. Thank you for being awake. In this case, I'm not going to be worried about my information on the x component right now. So I want to solve for time. So my distance in the y direction is my initial velocity in the y times time plus 1/2 times my acceleration in the y direction times t squared. Put this over here so we don't want to look at that stuff. This looks very similar to this equation that we've been using forever. All I'm doing is making sure I'm putting things in my y direction. That's why I'm having my x covered up, because I do not want my x stuff. Yes?
After dy equals, that's vi.
Vi times y, yes, VIY. Initial velocity in the y direction. Times time plus 1/2 a in the y direction times t squared. So then I'm going to fill in what I got. 10 meters equals 0 times time plus 1/2 times 10 t squared. Zero times time is always 0. Sum over 10 equals 1/2 of 10 is 5 t squared. So that my t squared is equal to 10 divided by 5 10 divided by 5 is 2. So t squared is equal to 2. I don't want t squared, I want time. So we're going to square root both sides. 1.4 and some change is my time. It takes 1.4 seconds for that ball to hit the ground. Remember, my time is the same on both sides, so I can fill it in on both sides for this one. So 1.4 seconds is that answer. That's what it was looking for. However, with projectiles, we like to ask more than one. So, how far from the base of the cliff does it land? So basically, now I want d of x, distance in the x direction. So at this point, now I know. Now I don't want the stuff on my y side. I'm only going to use the stuff on my x side. So same formula, distance equals initial times time plus 1/2 at squared. Now though, I'm only going to look at that x side. So when I plug in what I know, this is what my formula looks like. D of x is equal to 5 times 1.4 plus 1/2 times 0 times 1.4 squared. What is 1/2 of 0? 0. What is 0 times 1.4 squared? 0. I don't need it. So my distance in the x direction is 5 times 1.4. Which should get you somewhere around 7 meters.